Okay, we've worked with fractions, adding and subtracting them, as long as they have the same denominator. And we found out that in order to add and subtract fractions, we have to have the same denominator. But what happens if we're adding fractions that don't have the same denominator? We need to figure out how this will work. Okay, well, whenever we added things that had the same denominator, we could look at it visually and see what was going on. For instance, if we were adding 1/3 plus 1/3, then that became 2/3 of our picture there. So that was very easy to do. Now, where it becomes more difficult is where we're adding things like, say, 1/3, which would be this portion of my picture here, and let's say we're going to add it to 1/4, which would be this part of my picture. Well, if I were to put those two things together on the same graph, let's say that a visualization. If I were to put those together on the same visualization that was broke up into parts of 3, then I could shade in my 1/3 just fine. But whenever I went to shade in this 1/4 part, I would have to shade in a portion of another third. So that doesn't work really nicely. I can't say now this is 2/3 because it's not. It's a third and then part of another third. So that doesn't work real well. Well, what if we were to add them in this visualization here where they're cut into parts of 4? Well, I could shade in my 1/4 very nicely, but if I were to shade in this 1/3 on this picture, it would shade in parts of another fourth and another fourth. So again, we can't really talk about it in terms of fourth parts or size 4 pieces. So there has to be a better way of doing that. Well, there is. But before we do that, we need to talk about a concept called multiples. So we need to know, first of all, what is a multiple? And whenever you think about and hear the word multiples, you should be thinking multiply. It's kind of a variation of the word multiply, right? Okay. Well, whenever it says to list out the multiples of a number, like let's say we're going to list out the multiples of 3, all we're doing is listing out every one of the multiplications of 3. So, for instance, 3 times 1 would be 3, 3 times 2 would be 6, 3 times 3 would be 9, and then 3 times 4 would be 12, and then we would keep going. 15, 18, 21, 24, 27, and 10 times 3 would be 30. So we're going to stop there. Now, if I were going to list out the multiples of 7, we would do the same thing. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, and we would keep going on and on and on. 28, 35, 42, 49, 56, 63, all the way up to, we're going to stop at 10. 7 times 10 would be 70. Alright, so this is just listing out the multiples. Now, if we look at these lists of multiples here, do we notice that they have some in common? Well, they absolutely do. And the smallest one that they have in common would be this 21. So the smallest of those multiples that they have in common is 21. Well, this is then the least common multiple. It's exactly what its name says it is. It's a multiple that both of those numbers have in common, and it is the smallest of those. So our definition says the least common multiple, or LCM, of two whole numbers is the smallest number divisible by both those numbers. And we're going to practice some in the next video.